So let me give you an example of an fMRI. So again, with an fMRI, you first got to have an MRI. So you basically have to sit there, with your head very still, right? Well, you hear the clanging of that whole machine going. It's important actually for an MRI and an fMRI that you remain extremely still, right? Because if you shift, the actual data will come from a slightly different location and the image will become blurry. So that's actually one of the disadvantages of this technique, is that you got to be completely stationary, often for a long period of time. So this is an example that's looking at two areas of the brain, looking at the fMRI signal, the changes in oxygenated blood flowing into a region, changes in blood flow in primary visual cortex, and in another area called area MT, which is actually part of what we'll talk about later as the dorsal pathway. This is information that's kind of heading into parietal, visual information heading into parietal lobe that helps to inform that spatial map of your body in relationship to objects and events out here in the world. So it turns out that primary visual cortex, right, cares about visual stimuli, cares about bars of light oriented in particular directions, while area MT has been shown to have its columns functionally organized based upon direction of movement, of moving objects. So things that are moving provoke activation in area MT, while anything visual tends to provoke activation in primary visual cortex, or V1. So they presented white dots on a black background, right, to subjects for about 30 seconds, right, because you got to acquire data over a period of time. Remember, MRI and fMRI and PET also don't have the best temporal resolution, but they have good pictures. So they're acquiring over like a 30-second period, or actually I think 40 seconds is what I indicate here, white dots on a black background, and then they shifted to a blank black background. This is your kind of control condition, right? And then the dots that were being shown in the experimental condition were sometimes moving, and they were sometimes stationary, right? So this is looking at the fMRI signal. This is sort of percent of percent of signal change from the period before. So this is like the blank background. So you're going to see this going to be sort of the stable state, right? If you're showing nothing there, this is the signal you're recording. Now this is area. These are moving dots, and this is from primary visual cortex, right? So you see this increase in the signal. This means more oxygenated blood is flown, and they're detecting more hemoglobin with oxygen in this region when you present something, visual on the screen. Then you drop back to a blank background, and you go back to your sort of baseline signal, right, in terms of blood flow. And then you go to the stationary dots, and you see again an increased signal, and then back to a blank background, and there's nothing, right? And then back to moving dots, and then back down here. If you go to area MT, for example, right, you're going to see with the moving dots, you see a pretty robust signal change, right? And then it drops again at the blank background, and then you present stationary dots, and area MT does not care about processing something that's not moving. So you don't see any increase in blood flow into the area to support any increased activity. And then you go to the blank background, and you go to moving dots again, and that's what really gets area MT to go. So this is a technique that can actually show you in a healthy human subject their brain in action, functional action in response to in this case different types of visual stimuli. And again, MRI and fMRI, in terms of their advantages, they take really good pictures. They're the best images, right, that you could possibly get. And in terms of their disadvantages, they don't have very good temporal resolution, although there have been advances in terms of, reducing the sort of temporal lag here. They measure blood flow changes and not actual neuronal activity, right? In addition, they're very expensive, right? These machines are not cheap. And you have to have, a physicist to help set up all the software and monitor the software and make sure that the information that you're focusing on is correct and you're adding the right, kind of grayscale values, or, you may have for functional level of activity, the right, you've got the right range of, color to add in to really show changes in activity that are related to the types of stimuli that you're presenting during these tasks. So, it's got advantages and disadvantages like all of these techniques.